Howdy. In this video, I'd like to show you how to use your calculator to solve equations. And the good news is that the calculator solves all equations in exactly the same way. It doesn't matter what type of equation you're dealing with, what type of function you're dealing with. You're simply going to find intersection points. So to get there, I'd like to consider this interesting problem. Sam lies on a rooftop 5.0 meters above the ground and looks straight out. His brother below throws a ball vertically upwards from the ground with a speed of 12.0 meters per second. For what times will Sam be able to see the ball? Assume that he cannot see below the roof line. Now, this is an interesting problem, and I think we probably need to draw ourselves a picture of what's going on. Here is our building with the roof line, and Sam is lying on top of that building, and he is looking out like that. And he cannot see below the roof line. Now here comes the ball thrown upward from the ground with an initial speed of 12.0 meters per second. And presumably it goes up like so, comes back down like so. Because Sam cannot see below the roof line, he is only going to be able to see when the ball is above his current height. Well, that gives us some insight into the problem, because if y is the ball's position, the vertical position, then Sam will be able to see whenever y is greater than 5. So all we need is an expression for for the ball's vertical position, and we're good to go. So let's come back over to our diagram, and let's slap a reference frame on it. Makes sense to put 0 on the ground and have up be the plus direction, the positive direction. So if we do that, then immediately we have an initial velocity of plus 12 meters per second. And of course, gravity pulls straight down with an acceleration of negative g. And the initial height is 0 meters. So now the ball is going to travel up and down, and the equation that governs its height is delta y is equal to y minus y0 is equal to v0t plus 1/2 at squared. And filling in the values here, we have 12 for the initial velocity, and we have 5t squared for our second term. And what we're looking at then is this inequality that we would like to solve. 12t minus 5t squared is bigger than 5. Okay, so how do we actually solve that inequality? What we're going to do is we're going to take it to the calculator as an equality. We're going to find the times for which 12t minus 5t squared is exactly equal to 5. And that will tell us the 2 times where the ball crosses going up, the roof line going up, and crosses the roof line going down. We're going to be looking for these 2 times right here. And all the times in between are going to be the times for which our ball is visible. On the calculator, we're going to solve this equation the same way we solve all equations on the calculator. We're going to let y1 be represent the left-hand side of the equation. And we're going to let y2 represent the right-hand side of the equation, and we're going to use second calc intersect to find the points where those 2 side equations, those 2 functions cross. Let's actually go to the calculator and see how this works out. Pull up your calculator if you have it. Actually get it if you don't have it so that you can track along here. Then hit the y equals button so that you can enter the 2 sides of the equation. I need to reproduce the equation over here so that we can see what's going on. Our equation is 12t minus 5t squared is equal to 5. What I'm going to do now is to let y1 be equal to the left-hand side of that equation. 12. The calculator uses x for all of its variables, so we're going to use x here. 12x minus 5x squared is our left-hand side. And now the right-hand side of that same equation is 5. So y2 is going to equal the right-hand side. Again, our slogan, y1 equals the left-hand side, y2 equals the right-hand side. Now, I'm going to need to set my window size so that the intersection points are clearly visible. And setting the window size is a matter of figuring out what reasonable values we can have for our two variables. What are our variables representing? In the calculator, the x represents the times, which was my variable t in the equation. And the y variable represents the heights, which is the variable y in our equation. And what we want to do for our window size is to set the minimum and maximum heights and times so that everything is visible. Well, what's the minimum height? Clearly, my height is not going to be below 0 because that's where the ball starts. And I figure that my height probably will not be much higher than 10 meters because Sam is on the roof line at 5. If it goes above 10, I'll be able to see it, but I don't think I'll care too much. What about the times? The times are tough. Clearly the problem starts at time 0, so I can do that. But for the other time, I have to kind of guess as to how long it's going to take the ball to go up and come back down. I don't really know. Based on what I've done before, throwing balls up in the air, I can say 5 seconds, maybe 10 seconds is probably safe. Let's go with 5 seconds and see if that works out for us. To get that window size, we're going to go back to our calculator and hit window. And we're going to set the minimum x to be 0 and the maximum x to be 5. That represents our t's. And the minimum y to be 0 and the maximum y to be 10. And that represents our heights. We're going to hit graph. And there it goes. There goes our ball up and down. And here comes Sam on the roof line. And his height is a constant 5. And what we're looking for are the two intersection points on the graph, which are here and here. Okay, and so we're going to find those using second calc. And the option that we're looking for is option 5, the intersect option. The intersect option is going to ask us for a first curve, and it's, I'll point out what's happening here. We've got a first curve question, and the default is going to be y1 equals 12x minus 5x squared, which is exactly what we want. So we just hit enter. Then it's going to ask us for a second curve option, and the default is y2, which is exactly what we did already, so we just hit enter. So we really just hit enter twice as the first thing. And then it's going to ask us for a guess. And the reason that we have to give a guess is that there are two intersection points, and we can only find one at a time. So we're going to work left to right and put our cursor on the intersection point on the left and hit enter. And when we do, we find that our intersection point is, of course, when y is 5, and it is when t is about 0.54 seconds. So our first solution is 0.54 seconds. That's going to be when the ball first becomes visible. Now we come back. Let me erase some of these dots here. And we're going to have to do the whole process a second time. By whole process, I mean the whole second calc intersect process a second time to find the second intersection point. So we again hit second calc and option 5 intersect. First curve enter, second curve enter. And this time for the guess, we're going to trace along until we get to the second curve, and we're going to hit enter again. And it's going to say intersection, and it gives us a second time of 1.86 seconds. Now we have to take our two intersection points and turn them into a reasonable answer to the question. The question was, for what times will Sam be able to see the ball? And the answer is clearly between these two times. And so we're going to say Sam can see the ball for t's between 0.54 and 1.86 seconds. And there it is. So to summarize, the way in which we use calculators to solve equations is we let y1 equal the left-hand side. We let y2 equal the right-hand side. We set our window size. And we use second calc intercept. Now, here's what you do to make sure that you're doing it right. Clear your calculator, clear the y1, clear the y2, and go back and solve this equation again until you can do it smoothly and get these two solutions. I will see you in class.